Hey guys, it's Mr. Peters here. We're in 13.5 and pre-calculus, and we're talking about the sums of infinite series. For those of you who want to kind of get into the reason behind this theorem that I've gotten written out right here, check out the Khan Academy video that I posted on LMS for you guys. For those who just kind of want to know what the theorem is and be able to apply it, carry on. So R, we know that that represents some rate that we're multiplying our terms by in an infinite geometric series. So let's say if R, if I'm looking at the absolute value of R, if that is less than 1, and that's important right here, if this is less than 1 in the geometric series that I've got written out here, T1 plus T1R plus T1R squared plus etc., right? Then I know that this converges to the sum of S equals first term divided by 1 minus R. This is a beautiful theorem because it's so simple, it's easy to remember, and it tells you that, hey, not only does this converge, it converges to the sum of some whole number, right? So this is going to give us, not necessarily a whole number, it's going to give us a real number that this converges to. All right, now, another important little tidbit here is written in light blue. If the absolute value of R is greater than or equal to 1, so that means my rate is growing, right? Every term is growing. Well, then my series has to diverge, right? There's no way that these are going to all add up to some value. No, they're going to diverge either to positive infinity or negative infinity. There's going to be no convergence. Okay, so let's look at a problem. Let's find the sum of this series, right? So I've got 9 minus 6 plus 4 minus blah, 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 right? So to be able to solve this, I just need to use my nifty little formula, right? S equals T1 divided by 1 minus R. It's so simple. What's my first term? Well, first term is just 9. And my rate, right, what is my rate? How am I moving from 9 to negative 6, and then from negative 6 to positive 4? Well, it looks like I'm taking 9 and multiplying it by negative 2/3, right? That gives me negative 6. I'm taking negative 6, and multiplying it by negative 2/3. What does that give me? Well, that gives me 4. All right, so there is my R. R is equal to negative 2/3. So I get to plug that in right here. Negative 2/3. Sorry, that is hideous. Let's change that guy up. Negative 2/3. So I'm taking 9, dividing it by 1 plus 2/3, or 1 and 2/3, and that gives me 27/5. Or you could write that as 5 and 2/5. Right? Who would have thought that if you were to take this and add every single term in this infinite series, they'd add up together to be 5 and 2/5? That's just wild to me. Super cool. Let's apply it to something a little different. For what values of x does the following series converge? Now, let's remember, for these to converge, the absolute value of my rate needs to be less than 1, right? The absolute value of my rate needs to be less than 1. Well, what is the rate, right? What is the R in this series? Well, it looks like I've got my T1 right here. T1 is 1. What have I multiplied 1 by to get x minus 2? Well, it looks like I multiplied it by x minus 2, right? What have I multiplied x minus 2 by to get x minus 2 squared? Well, it looks like we multiplied it by x minus 2 again, right? Etc., etc. So R, in this case, is equal to x minus 2. So for my values of x, I just need to plug these in for R, right? I can utilize this little tidbit here to solve for the inequality, right? I'll be able to find all possible values of x such that the absolute value of R, my rate, is less than 1. I can replace R with x minus 2, right? I need this to be less than 1. Well, when you've got the absolute value of x minus 2 being less than 1, this is the same thing as saying, well, 1 is less than x, which is less than 3, right? So that right there is my conclusion, right? I can say the interval is where this series will converge. This is called the interval of convergence. The interval of convergence. This is a good test question, right? The interval of convergence is just the interval for a series where it will converge, right? What values can you plug in such that this converges? So that is what our interval of converges is. I've got one other problem for us to kind of look at, right? So I've got a repeating decimal, 0.45 repeating. This can be written as an infinite series, which I think is just wild that you can take a repeating decimal, or just the person who thought of this to say, well, let's take 0.45 and then add to it 0.0045, and then add to that 0.000045, etc., right? That is 0.45 repeating, just written out as a sum, which is super cool, I think. Well, if we want to find this sum, all I need to know is what T1 equals. I need to know what R equals, and then I can plug it in to my summation formula. All right, so what is T1? Well, it's right here for me, right? There's T1, 0.45. My rate, what am I multiplying 0.45 by? What am I multiplying it by to get 0.0045? Well, that looks like it's, 1/100th of the previous term, so that's times 0.01. My R is 0.01. Therefore, my sum is 0.45 divided by 1 minus 0.01, or 0.45 over 99, over 0.99, which is 5/11ths. The summation of 0.45 repeating written as an infinite series is 5/11ths. All right, homework is posted on LMS. You guys let me know if you have any questions. Stay safe, stay healthy, stay wise.